Hello, today I'm going to talk about dental wear during childhood and how it can be used to study the diet of children. This is a topic I've been working on for quite a bit of time now as part of the VAMOS project here at OREA. The VAMOS, or Value of Mothers to Society project, led by Katarina Ribay-Salisbury, is an interdisciplinary ERC project exploring motherhood in late prehistory, particularly here in Austria. You may have seen this publication in Nature about traces of milk in ceramic baby bottles. One very important aspect of motherhood is, of course, breastfeeding. As we are mammals, our children begin life on a diet of milk and later transition to solid foods. This is what we call weaning. In most primates, this actually occurs around the time of eruption of the first permanent molars. So that would be 6 years of age in humans. And this helps the child process food. Weaning this late decreases fertility due to a phenomenon known as lactational amenorrhea, which is the loss of the menstrual cycle during lactation. And this also increases interbirth spacing. In most forager societies, weaning occurs quite late to allow the dental system time to develop to process coarse foods. And this, in turn, reduces fertility, which can be quite important for nomadic people, because you have to carry children. In sedentary agrarian societies, an increase in the availability of suitable soft foods allows weaning to actually occur earlier. This increases fertility. As children age, other foods are introduced into the diet. The availability and composition of these foods can vary with gender and socioeconomic status. So my work has really been centered around the relationship between the physical properties of food and the accumulation of dental wear. And this is a topic of my PhD, macroscopic and microscopic tooth wear in a developing juvenile dentition, ontogeny, and the study of diet in past populations. So the objective of this project is to explore the use of dental wear to answer questions about childhood diet and the availability of certain foods in prehistoric societies, such as those studied by the VAMOS project. Dental wear refers to the changes that happen to the tooth as it is used. The study of use wear is called tribology. So dental wear is a complex tribological system. So there are multiple factors such as abrasives and acidity that are influencing the process. It can be studied in terms of macroscopic changes to the tooth or by studying the microscopic surface of the tooth. There are multiple interrelated factors behind tooth wear. In order to study diet, you must therefore account for the age of the individual and, if possible, make sure there are no abnormalities in occlusion and pathologies such as bad carious lesions that can influence how the individual chews. Tooth wear begins when a tooth erupts and, in an archaeological context, generally ends when the individual dies. The rate of this wear can vary with a number of tribological factors. It varies quite a bit between foragers, agriculturalists, and industrialized populations. However, differences have historically been quite tricky to detect within these groups. I will actually mostly talk about dental microwear today, but we will briefly touch on paleodietary reconstruction with macrowear towards the end of the talk. The technique I use to study dental microwear is called occlusal 3D dental microtexture analysis using scale-sensitive fractal analysis, or DMTA-SSFA for short. So to do this, basically, to describe the texture of the enamel surface, the microscopic scale, you need to make a 3D model of this surface, and you do this by with a white light confocal microscope. And so you extract the area of interest by cutting it from a high resolution mold of the tooth, and then you place it under the microscope and make the 3D model, and then using some specialized software and the algorithms, you can describe the texture with a number of variables. So it provides a quantitative description of the surface, and this can be done on archaeological artifacts also, by the way. The texture variables that are the best understood in terms of DMTA are complexity, which is sort of how rough the surface is, and anisotropy, which is the alignment of scratches on the surface. So how can we best understand the microwear texture measured on the surface of the teeth of children? There have been a few publications on this topic over the last few years, and there are more and more. And taking these into account, and also my own understanding of dental tribology, this is how I understand this process in children. So first, obviously a child is born. The mother or caregiver breastfeeds the child, or sometimes the child is bottle fed. And at some point, then they begin to supplement this milk with other foods. This is the beginning of the weaning process. After the eruption of the second deciduous molar, around the age of 3, the child adopts the typical circular mastication. If by this time the child is already weaned or is being weaned with soft foods, and these foods contain abrasive particles, then we can predict that surface anisotropy will increase. Scratches are forming. If any of these foods are quite hard, so will complexity, so pits will form because the child is biting down. If the child is not yet being weaned, their surface will remain relatively featureless. So it doesn't mean there will be nothing, but there'll be less features, far less than if they're actively chewing. And the teeth will wear less overall on a macroscopic scale too. By the time the first permanent molar erupts, we expect the child to be weaned, in most cases, or at least towards the end of the weaning process. And after that, variations in the texture would indicate differences in the properties of accessible foods. These potential variations that could be observed within a population are very interesting, because it's been documented that access to foods can depend on a number of factors for children. Certain rich foods can only be accessible to those of higher socioeconomic status, and in some societies we observe also differences in the food available to girls and boys, with boys typically being given access to more higher protein foods like meat. So we recently published a paper to explore the use of dental microwear to compare the diet of children within a community. I apologize for the wordy title. It's somewhat technical topic. But what we did is we looked at unaltered deciduous teeth from a collection called the Tooth-Wear collection, or Collection Petite Souris, that was gathered by the people who supervised my master's thesis, actually, in Bordeaux, Brice Lebeil and Mona Leluyer. So if you're interested in such a sample, I recommend you check this out. We looked at 12 individuals from this collection and another 4 medieval individuals for comparison. As the tooth wears on the macroscopic scale, these flat surfaces form, which are called wear facets. These are caused by tooth-on-tooth contact. This is called attrition. And these facets have different numbers associated, and these are linked to the function and position on the occlusal surface. And what we did is we looked at the microwear texture at multiple locations across these wear facets. So 3 locations on facet 9 and 1 on facet 11 if it was present. What you can see also here is that as the tooth wears, these facets become larger. This is what the surfaces look like under the microscope at different locations on a single wear facet for 3 different individuals. And as you can see, they're somewhat similar in appearance. However, when you measure the texture of these surfaces, you find there is some variation. This suggests that location matters. When comparing large samples, this tends to average out. However, in small samples, like those you get when you're subdividing by age, or if you have a small archaeological sample, or if you're trying to compare individuals, this variation across the surface may actually account for any subtle differences that you measure. So this is a figure of the dispersion of measurements for 4 different variables across the wear facet. And you'll notice for some individuals, so this top left box, this is surface complexity. And some of these individuals actually have very high complexity values. And typically, if you measured this in an archaeological context, you would probably consider these individuals have been damaged by taphonomy. However, in this case, we know that these individuals weren't damaged by taphonomy because they were naturally exfoliated teeth that were donated. And so I propose the hypothesis that maybe these high values could be due to the exfoliation process. As the tooth is being shed, these very pitted surfaces are forming. The takeaway from this study is that it's difficult to compare individual children because in archaeological samples you generally don't have much choice where you can measure. And additionally, other factors, ontogenetic factors, seem to be affecting the formation of microwear. This is something that was also noticed in previous studies by other authors. So in light of this, we recommend separating children into age groups and taking into account that the changes are occurring throughout childhood. So differences between two age groups might not necessarily be due to diet, and also to try to limit the interpretation to relatively big differences in microwear, and to study more subtle differences. We need to be able to account for this variation across the wear facet, or to average it out by comparing large enough group sizes. But getting large enough group sizes is not always easy. I will not present too much the data from the archaeological samples today because some further analysis is needed, but I studied some Bronze Age individuals, mostly from Franzhausen here in Lower Austria, and additionally some medieval individuals from St. Pölten, also in Lower Austria. But one factor that seems to be really influencing the available sample sizes is the amount of alteration to the occlusal surface caused by taphonomic processes. So here you can see a surface that maybe to the untrained eye might seem okay, but in fact it's badly damaged and can't be used in dietary analysis. So for now, one thing that I can say is that weaning, where it does agree with the idea that weaning is occurring relatively early in the Bronze Age population and the medieval population, but this is like we would expect for an agrarian society anyway, so it's not so surprising. And for investigating more subtle variations in dental wear, and weaning, for example, this is proved difficult due to the sample conservation. But there is some data that's interesting, so I am still working on this. Now, macroscopic dental wear is less sensitive to these taphonomic processes, which is cool. It means we can have larger sample sizes, but it does not quite reflect the same properties of diet either. Wear rates on the macroscopic scale increases with exposure to abrasive particles mostly, and the amount of chewing, for example. Traditionally, dental wear is studied using qualitative ordinal scales. So this is like this extract that I put here from Molnar 1972, where you see there's different stages and with a description for each stage. And these methods have been successful at differentiating wear rates, so often by comparing the first permanent and second permanent molar, and then you can see how much wear has occurred in the 6 years between the two. And you can distinguish between foragers, agriculturalists, and industrialized societies. But it's very difficult to study more precise variations because the ordinal scales are quite limited in their precision. So after the last few decades, there's been a number of measures that have been proposed to quantify the progression of dental wear, provide a quantitative description. One that's been suggested is the measurement of crown height, but another study found that this didn't yield particularly much better results than the qualitative methods. And then one system, for example, is to use the percentage of the occlusal surface with exposed dentin. And I'm sure this works quite well on adult individuals. The only issue is that in children, most of the wear we're interested in actually occurs before dentin exposure. So you'd seriously be limiting yourself if you use only this. And then there are sort of more advanced methods for analyzing dental or macrowear, like occlusal fingerprint analysis, like OREA. And this method is very good. You basically describe the wear facets in detail to reconstruct master mechanics. However, the use is not widespread. It's quite involved, time-consuming. Mostly I've seen the studies come from Frankfurt for the moment. And yeah, its use is not widespread. And it's generally applied to small samples of great interest, like Neanderthals. Probably due to because a lot of it's manual. Furthermore, its applicability to dental wear during childhood is still unknown. A lot of work would have to be done on this too in order to apply this method. So maybe in the future, but for now, this wasn't so much an option for me. So what I opted to do was instead to try and figure out another way of measuring dental wear. So this is kind of exploratory. So I was trying to find a way that's the best suited to detecting subtle differences in the accumulation of dental wear during the first years of life. And so today I'll give a short preview of this work, just to give you an idea of what it is and what it could do. And so thanks to collaborators in a dental clinic at the Medical University of Vienna, I was put in touch with a company called Plandent, who were kind enough to lend me a Planmaker Emerald intraoral scanner for this project. This is an awesome device which allows you to build a 3D model of dentition by passing a camera over it. So it builds the model in real time. It's quite impressive. Once I had scanned about 150 dentitions, the next step was to look for features that vary as the tooth wears. So I settled on two features that are related to the curvature of the occlusal surface. The first is the angle of the interior slopes of the mesial cusps of upper molars, which gradually increases as the occlusal surface becomes flatter. And the second measurement I made by mapping the local surface curvature across the 3D model, and then in image J doing a simple grayscale thresholding to sort of segment out the relatively flat surface areas. And this increases in percentage of the occlusal surface as the tooth wears, at least before dentin becomes exposed. My early results show that this method detects more subtle differences in diet when compared to a qualitative alternative, but it is still a work in progress. If you're interested, definitely keep an eye out, because I intend to publish something on this method in the coming year. Also quickly, one cool thing is that now we're able to compare boys and girls using amelogenin peptid analysis to determine the chromosomal sex of the individual. If you want more information about this, I'm sure Katerina Rives-Salisbury can talk about this, or Fabian Kans, who's my thesis supervisor. But I'm involved in the peptid extraction, so I can say that it's going well. So to finish, my take-home message today is that the physical properties of food available to parents to wean and raise their children has an impact on fertility, health, mortality, and the experience of motherhood in the past, and therefore we are investigating the properties of food through their impact on macroscopic and microscopic dental wear. Although more research is needed, it is worth considering this approach perhaps alongside isotope ratio analyses for investigating these topics. So definitely keep an eye on future developments in this field. Thank you very much for watching this video, and please don't hesitate to get in touch if you have any questions or ideas, suggestions, anything. Thank you, and have a good day.